Hey everyone, let's jump right into this explainer. Today, we are talking about how PowerAsset Orchestrator is completely changing the way we manage enterprise data centers to actually make them sustainable. If you've been paying any attention to the rapid acceleration of artificial intelligence lately, you know that the compute demands are just absolutely skyrocketing. I mean, consider this for a second. A single AI prompt can consume up to 10 times the power of a standard search query. 10 times! But what we don't always talk about is the massive, undeniable footprint that all this compute leaves on our actual power infrastructure. So we are going to look closely at a really fascinating approach to solving this exact problem.
This right here is the core dilemma for IT admins and chief sustainability officers today. Honestly, it's the million-dollar, or let's be real, the multi-million-dollar question. On one hand, you've got these massive, incredibly power-hungry compute needs driven by AI training and inference. And on the other hand, you're dealing with skyrocketing energy costs, aging public grids, and really strict service level agreements that guarantee uptime to your clients. Trying to balance this equation manually is just becoming nearly impossible.
To really understand the solution, I want you to think of your modern data center as a massive, complex orchestra. But right now, it's divided into two completely separate rooms. Over in one room, you have your energy assets, things like the public power grid, your on-site power plants, or natural gas reserves. And in the other room, you've got your high-performance server racks and GPUs. Traditionally, these two sides just don't talk to each other in real time. The servers just consume whatever they need, and the energy side blindly provides it, totally regardless of the cost or the strain it's causing.
Which brings us to the intelligent conductor, the PowerAsset Orchestrator, or PAO for short. To bring those two totally disconnected sides of your infrastructure into perfect harmony, you need a master conductor. And that is exactly what this next-generation energy management platform was built to do. PAO is designed to orchestrate and control all your power infrastructure assets, whether you're fully connected to the grid or operating entirely behind the meter. Because it's seamlessly integrated with SuperCloud Composer's architecture, it gives administrators unified, real-time visibility and control over the entire ecosystem, right from a single dashboard. We're talking monitoring the grid, your battery energy storage systems, your backup generators, all in tandem with your actual data center infrastructure. You finally get that complete top-down view. Let's move on to how this actually helps in optimizing energy and costs to master efficiency. So you might be wondering, how does it actively save an enterprise money without someone constantly tweaking the dials? Well, it bridges the gap between managing infrastructure and financial efficiency by using something called LMP, or locational marginal pricing. You see, energy isn't just a flat rate. Market prices fluctuate all day long based on demand. By pulling in real-time locational marginal pricing, PECO continuously evaluates your exact cost per kilowatt hour. It dynamically reacts to price spikes or drops, literally like a conductor changing the tempo of a symphony. When energy is cheap, it draws heavily from the grid, but the second prices spike, it instantly identifies that change and pivots. And that ties directly into another absolutely vital concept: PUE, or Power Usage Effectiveness. This is basically the gold standard metric for data center efficiency. PAO provides continuous, real-time PUE insights. But it isn't just passively reading a meter. It takes that data and uses it for intelligent, automated orchestration. If your cooling systems need a slight adjustment, or if you need some load shedding to happen, PAO just handles it. This drastically lowers operating costs while making sure you're still hitting those SLE compliance goals. It literally schedules tasks to perfectly balance peak performance with the lowest possible energy cost.
Up next, we're looking at smart GPU workload automation with a feature known as GPU FLX.
Okay, so how does this overarching power management actually impact the rock stars of your orchestra? I'm talking about the power-hungry GPUs running your complex AI workloads. Through GPU FLX, POX completely autonomously to manage your compute loads. First, it constantly evaluates the real-time power availability and thermal conditions of your servers. Then, based on that specific data, it dynamically scales your NVIDIA, AMD, or Intel GPU workloads up or down. And if needed, it seamlessly shifts those workloads across entirely different clusters. This guarantees seamless resilience, meaning your GPUs stay powered and available, even if the main grid is having serious fluctuations. And this really illustrates the kind of flexibility we are talking about here. Imagine your high-performance GPUs are sitting right alongside your battery energy storage systems. Suddenly, the public grid spikes in price because of peak afternoon demand. In the old days, you might have to pause jobs, but PAO doesn't just shut off your vital AI training. Instead, it effortlessly shifts your power reliance over to your on-site batteries. It keeps those GPUs humming, keeps your workloads progressing, and keeps your costs aggressively minimized. It's a total game changer.
But to do all this, we need the senses of the conductor, powered by Bentanis Edge version 1.0.
Because think about it, to make these high-stakes split-second decisions, the orchestrator needs highly sensitive eyes and ears. This is exactly where the hardware meets the software. The sensor-driven Bentalis Edge board is just an incredible piece of IoT tech. It constantly feeds PAO actionable environmental feedback through multi-sensor inputs. We are talking real-time down to the millisecond data on temperature, pressure, humidity, airflow. It even uses differential pressure to tell you exactly when your air filters need maintenance. Plus, there's a camera and vision port for security and visual diagnostics. This rich, continuous feedback loop enables super proactive facility management and lets the system auto-scale cooling resources on the fly. All that data feeds directly into the autonomous AI brain, whether that's an on-premise or cloud-based large language model.
So all of this environmental, financial, and hardware data, it doesn't just sit on some static dashboard for a human to look at. It feeds directly into the PAO AI agent. This is a built-in large language model designed specifically to execute task-oriented operations across both your energy grid and your compute infrastructure. And the interface? It is remarkably intuitive. You can literally just prompt the agent with natural language, asking for real-time insights like, hey, what's my device-level power consumption right now? Or show me the PUE scores and GPU workload metrics. But here is the kicker. It goes way beyond just answering questions. This AI agent is fully capable of directly controlling integrated assets, from your power distribution units straight to your generators, using low-latency, autonomous decision-making right at the edge.
If we compare the traditional paradigm to what PAO offers, the difference is night and day. Typically, administrators are constantly navigating these complex, fragmented manual configurations. And worse, they're usually only reacting after downtime or a thermal event has already happened. But with PAO, AI-driven business rules dynamically adjust your compute loads. It optimizes training jobs or ramps up resources to capture massive financial savings automatically, without you having to lift a finger, and without ever disrupting your enterprise operations. It's a complete shift from reactive firefighting to proactive, intelligent automation. And crucially, this isn't some rigid, one-size-fits-all magic box. PowerAsset Orchestrator is fundamentally built for true enterprise scale, demanding low latency and highly flexible deployment. So whether your organization needs to deploy entirely on premises for maximum security, or if you want to leverage a hybrid model or even run the whole shebang entirely in the cloud, PAO delivers a robust, scalable framework that's actually tailored for the messy realities of modern data center orchestration.
So I want to leave you with this final vital question to think about. As AI workloads continue to multiply over the next few years, is your data center merely consuming power, or is it intelligently orchestrating it? The days of treating your energy and your compute as two separate silos are completely over. Thank you so much for joining me for this explainer. Hopefully you're walking away with a much clearer picture of how tools like this can help you build a truly intelligent, resilient, and sustainable infrastructure. Catch you on the next one.